In this three-part tutorial, I'm going to demonstrate how to set up and run a multi-signal STEM spectrum imaging experiment on the GIF Continuum. Part 1 covers the Digiscan and filter setup steps. In Part 2, I'll show you how to set up and acquire an EELS and EDS spectrum image dataset. Finally, in Part 3, I'll demonstrate how to set up and acquire a 4D STEM and EDS spectrum image dataset. Right now, I'm in the STEM SI technique already, with the microscope set up and aligned in STEM mode at short camera length to give a collection angle optimal for EELS. If you'd like to know more about how that's done, just refer back to the STEM alignment and setup video that forms part of the GIF Continuum tutorial series. Right now I'm looking at a live image from the ADF detector. The sample we are looking at is a fib lamella that was prepared from a multi-layer thin film. The substrate material is strontium titanate, then a bismuth ferrite layer, followed by an iridium layer. The first thing to do is change the scan rotation to make the interfaces parallel to one of the image axes. To do this, just right-click on the live scan to show the Tools menu and activate the True Align tool. Next, draw a line along the interface. The software then asks if we want to align the scan direction horizontally or vertically. To minimize specimen damage, it's better to scan perpendicular to an interface, so I'll choose Align Scan Vertically here. Next, activate the focus loop by clicking on the focus button in the scan palette at the top of the Technique Manager. Use the focus control to set the best focus. While the focus loop is active, the up and down keys double or halve the pixel dwell time. The right and left keys double or halve the pixel density. Increasing the sampling density and pixel dwell time is a useful way to increase the signal-to-noise ratio and pixel resolution, which can help you really optimize the focus well. Now the image focus is good, let's move on to setting up the EELS spectrum. Make sure the continuum is in EELS mode by checking the microscope UI at the left-hand side of the software. For mapping, we want the maximum signal and a big energy range, so it's usually best to start with the lowest energy dispersion and the large high SNR GIF entrance aperture. Low dispersion means big energy step size per channel. I am using 1.5 eV per channel here, which gives an energy range of around 3000 eV. Next, check the color indicator in the tune palette under the microscope UI. The filter tuning is saved for different microscope states. Green means that the current state is good. Right now we don't need to retune, but for the purpose of demonstration, I'll show you how to use EELS autofocus correctly. First of all, stop the scan and make sure spot mode is enabled. The red cross on the image is the beam park position. Make sure the park position is somewhere safe. Here the beam is parked on an amorphous platinum, a long way from our interesting area, which is good. Next, go to the EELS palette. I'm using single EELS mode, but any of the live spectrum modes would be fine. Make sure HQ mode is active and the energy is set to 0 eV, and make sure that exposure time is 1 microsecond or shorter, and then start a live spectrum view. If the zero loss peak is not at 0 eV, click on Align ZLP. That isn't the case here, so I'll just go ahead and click on Autofocus to focus the spectrum. Once autofocus is complete, go back to the EELS palette and use the periodic table to choose an energy offset. The lowest energy signal we have here is the titanium L edge, so I'll choose titanium. This gives us enough energy range to collect the titanium, oxygen, iron, strontium, and bismuth signals for mapping. Switch on auto exposure to optimize use of the detector dynamic range and start the STEM live scan again. This is a good first approximation for an optimized EELS exposure time for a single spectrum. It's possible to use even shorter exposure times and still get very good capture data and maps, as both make use of HQ dark correction. Make sure to use preview mode and not search. That's all for part 1. To learn more about simultaneous EELS and EDS spectrum imaging, check out the multi-signal spectrum imaging tutorial part 2.